Hi, from chapter 16, we will learn thermodynamics. Okay. Chapter 16 is on temperature and heat. If the two systems are placed in contact, for example, if you put a bottle of water inside of a refrigerator, then what happens is usually, or if you put two metals, one hot metal and the other cold metal, put in contact, what happens is macroscopic property such as length or electrical resistance of metal, or if you put two gases, hot gas and a cold gas put together, then the pressure, even liquid, bottle of water, liquid pressure can change. So these macroscopic properties keep changing until those systems become in thermodynamic equilibrium. When those macroscopic changes, electrical resistance, pressure of gas, length of solid or something, all those, that can be measured, macroscopic properties, changes that can be measured, stops changing, then those two systems are in thermodynamic equilibrium. Okay? When two systems are in thermodynamic equilibrium, then by definition, they are at the same temperature. So how do we measure temperature? We can measure temperature by using these changing macroscopic properties. By using thermometer, usually we measure temperature, and thermometer measures temperature by using changing electrical resistance of the system as a function of temperature, or for example, change of volume or length of mercury column. Mercury thermometer usually used at home, that uses mercury volume changes. This liquid volume changes as a function of temperature, and gas pressure changes also as a function of temperature. So you can measure, if you can measure gas pressure, you can measure temperature. So thermometer is a small system that can measure the changing macroscopic properties of these. Those changing value can indicate the temperature. For example, gas thermometer this is gas thermometer. So here is vacuum, and this is, for example, mercury liquid here, this part. And here, this part is filled with some gas. And you put this end inside some, for example, something that you want to measure temperature. As you know, ideal gas law, even if it's not ideal gas, gas pressure, gas volume changes with temperature. It expands at a high temperature, and contracts. Gas volume decrease with lowering temperature. So the volume pressure changes usually linearly with temperature. So this height h changes as a function of temperature that is measured at this point. So this gas thermometer uses the property gas pressure changes with temperature to measure temperature. How do we define the unit of temperature? Normally we use SI unit, which is Kelvin or degree Celsius. So one of the points is triple point of water is 273.16 Kelvin. This is one defined position. Triple point of water is very unique temperature where solid, liquid, and gas of water phase can coexist only at one position here. At that triple point, temperature is defined as 273.16, and so we know this point it's near 0 degrees C, and you measure some, for example, using some gas thermometer, you can measure gas pressure as a function of temperature while lowering the temperature. You record the pressure, then the pressure we know this position here at one position, gas pressure. This is 0 degrees C or 273.16 Kelvin. And there are other temperature scales as well. Celsius with 0 degrees C is 2.2, as you hear, 273.1, actually 15 Kelvin. which is freezing point of water under normal condition. And Fahrenheit, for example, United States use Fahrenheit. Here's a conversion. So 32 degree Fahrenheit is 0 degrees C. And Rankine, I haven't seen any country use this Rankine, but some places still maybe use this temperature scale. So usually if two objects are in contact or are close together, the object having two temperatures are close to each other, then energy flows from high temperature to low temperature. That energy is due to temperature difference. Energy flow that flows due to temperature difference is called heat. Older unit of thermal energy is calorie. 1 calorie is 4.18, around 4.2 joule. Heat, how much heat is required per unit temperature change? This is heat capacity. It changes not only from material to material. For the same material, if the mass increases, then the heat capacity increases. So it's not a unique property of a material, but specific heat is defined as heat capacity per unit mass. So when two systems are in contact and their macroscopic properties start changing, but eventually their macroscopic properties stop changing, then they are in thermal equilibrium. And then we say, by definition, they have the same temperature. If they are at same temperature, then they stop exchanging heat. So how is the heat transfer? There are three common mechanisms: conduction, convection, and radiation. Conduction is usually the method of heat transfer through solid. Convection is heat transfer through bulk flow of fluid. And radiation, finally, is through electromagnetic waves. The radiation power is spectral radiance, is radiation power per unit wavelength. In the certain wavelength range, how much energy is radiated. At high temperature material at high temperature, you can see that there's a peak. So it radiates almost all wavelengths of electromagnetic wave, but most likely, the intensity of the wave radiation is peaked at certain wavelengths. For example, like room temperature is around 10 micrometer. Object at room temperature, the peak intensity of the radiation is around 10 micrometer. So 10 micrometer is here in this range, right? This is in meter. 10 to minus 5 is 10 micrometer. This is called infrared. As the temperature becomes lower, the peak intensity becomes higher. So that means it goes this way. Wavelengths increase as temperature decreases. As temperature increases, peak wavelength of the radiation decreases, peak in radiation. So this is called Planck's law. Hot object radiates more energy than the cold object, of course. Depends on temperature to the fourth. The most important part here is the radiated power, how much radiation energy generated by a hot object is proportional to the fourth, temperature to the fourth. That means rate of energy gain should be equal to the rate of energy loss. So, for example, if you want to keep your house, if your room at a constant temperature, you should generate some energy which is equal to the energy loss to the outside. In a winter, it'll keep losing energy to outside because outside is cold. Then it should generate some energy, keep generating energy to balance maintain the constant temperature. To increase the temperature, what should we do? Decrease the temperature, we need to give less heat and eject more heat out of the house. Then if loss exceeds gain, the system cools down. If the gain exceeds loss, if energy gain is greater than the loss, system warms up.